In this video, we discuss one sample means with the t-distribution. In the first exercise, we see that a recent Gallup poll asked Americans to disclose the number of books they read the previous year. If initial survey results indicate that the standard deviation is 16.6, estimate how many Americans need to be surveyed to be within 4 books with a 95% confidence. So to do this, we'll use our sample size formula from the formula sheet. It says that n has to be greater than or equal to the critical z-score times the standard deviation divided by the margin of error squared. The critical z-score, the z-star, can be found on our formula sheet. So we have to note the confidence level, 95%. So the critical z-score for 95% confidence is 1.96. So 1.96, and then we multiply by the standard deviation, 16.6. We divide by the requested margin of error, which will be within 4 books, and then we square the entire quantity. So that works out to be about 66.16. So in other words, n has to be greater than or equal to 66.16. So 66 is not greater than or equal to 66.16. So we need to talk to 67 people. In the next exercise, it says a Tootsie Pop is a sucker with a chocolate candy center. In a famous commercial, the question was asked, how many licks does it take to get to the center of a Tootsie Pop? In an attempt to answer this question, a survey of 92 volunteers were asked to count the number of licks required to reach the chocolate center. The mean number of licks was 356.1 with a standard deviation of 185.7. Find and interpret a 95% confidence interval for the number of licks required to reach the chocolate center. So to do this in GeoGebra, we enter in the confidence level, 95%. We enter in the mean. The mean number of licks was 356.1, standard deviation 185.7, and there were 92 in this sample. So to do this in GeoGebra, we'll open up GeoGebra. We'll go to the probability calculator. Since this is a mean, and this is a confidence interval for a mean, we'll go to the t-estimate for a mean. We enter in the desired confidence level, 95. The mean for the sample was 356.1, and the standard deviation, 185.7. There were 92 people, and we see below here the confidence interval. 317.6 is the lower limit, 394.6 as the upper limit. So our confidence interval is 317.6 to 394.6. To interpret that, we say there's 95% confidence that the interval between 317.6 and 394.6 captures the mean number of licks required to reach the chocolate center. How much do Americans spend eating or drinking? Suppose for a random sample of 1,001 Americans aged 15 or older, the mean amount of time spent eating or drinking per day is 1.22 hours with a standard deviation of 0.65 hours. Construct and interpret a 90% confidence interval for the amount of time Americans 15 or older spend eating and drinking each day. Well, the number of hours spent eating is quantitative, so we'll be using the t-distribution. So to do this in GeoGebra, we'll open up GeoGebra here. This is, again, a t-estimate for a mean. So we'll put in the desired confidence level, which is 90%. The mean is 1.22 hours. standard deviation 0.65, and there were 1,001 in the sample. And we see the confidence interval here, the lower limit 1.19 and 1.25 to 2 decimal places. So we can say that we're 90% confident that the interval from 1.19 to 1.25 captures the mean amount of time spent eating or drinking per day for all Americans age 15 or older. Then we want to answer two questions. What would happen to the confidence interval if the confidence level decreased? So if we were less confident, if you think of a net, if you think of a confidence interval kind of like a net that we're using to capture a parameter, we would be less confident if that net were narrower. And vice versa, we would be more confident if the net were wider. So if the confidence level is decreasing, then we can say that the confidence interval would be smaller. Everything else held the same. So what would happen to the confidence interval if the sample size decreased? Well, if the sample size decreases, then you'll have less information, and to make up for that, you would have to have a wider confidence interval. Right? In general, we want narrower confidence intervals if we can. So decreased sample size would give you less information, and therefore we would expect the confidence interval to be wider.